So organizing quantitative data is another thing we're going to do, and obviously quantitative just means numerical values that are grouped together. And so determine if data is discrete or continuous. Discrete means countable, while continuous means data falling within a range with many different values. So to construct a histogram, we will first need a relative frequency distribution table. So a histogram is constructed by drawing rectangles. The height of each rectangle is the frequency or relative frequency of the class. The width of the rectangle must be the same for all rectangles, and they must touch. We'll construct a histogram using the data on the next slide. So we've got the following. Suppose we are given the following data, and it is tallied as the following. So we're going to do this for the frequency distribution. The frequency distribution is what we call, sorry, I'm looking for my pen, is what we call, why is this thing, there it goes, okay. Sorry about that, it's like, I don't know, it's not popping up my, come back, go back, come on, okay. And the show. So, here we go. We are going to do this. So I'm going to need this. Okay, we're going to just take this, not save, copy. So we're going to put this into a whiteboard. Okay, and then we will what? Why did it rotate? What is this? What is this foolery? There we go. All right, so what we're going to do is we're going to construct this for a discrete one. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, that's our first thing. Oops, I don't want to draw it that low. So I'll go like this. And our biggest frequency is 11. Our smallest one is 0. So let's do 0, 2, 4, 6, 8, 10, 12. Okay. So we fit everything. Everything is kind of synchronized. So our goal is to draw rectangles and match these relative frequencies. So here's 1. Actually, I'm going to need to draw that a little bigger. So this is 1. 2 is going to be 6. So we're going to go up here to 6. That doesn't fit very well. So let me draw this 1 a little bit bigger. Oh, I missed. We want them to be about the same size and shape, or same size in width. We want 1. Sorry, this isn't going very well. It's easier when I'm on the board. 4 is 4. Sorry, that doesn't look very good. So let's go to 4. Oh, I drew that too wide. 4 is this. 7 for 5. Okay, there's 7. 11 is all the way up here. 5 is right here. Actually, that's 5. Hold on. If that's 5, then 4 is lower, so I'm gonna correct that. This is 4. There we go. 2. So we've got 2 here. We've got 2 again. No, yeah, 2 twice. So let's make that a little bit wider. 2, 2, 0, and then 1. Okay, so we've got all that. And I don't like that first one, so let's make that first one a little bit smaller. And let's make this one over here a little bit smaller, but we'll also make it a little bit wider too, just so that they match. Okay, there we go. So notice I tried to make them the same width, but you can see the frequency distribution from this. It's not very hard to do. It's just keep them next to each other if you're doing a histogram, and do that. If we were going to do this for the relative frequency, it would be the same thing, only over here these would be decimals and they would reflect these values. Now sometimes the relative frequency is a little bit easier to do because if you're dealing with really big numbers, for instance, if you have one of your numbers is like 10 and your other number is 1,000, it'd be hard to fit that into this chart and then kind of know what it is talking about. So sometimes it's easier to use a relative frequency because that will keep it between 0 and 1 in all instances, and you'll be able to see how big the other one is in comparison. And so I hope this helps, guys. I'm going to end this video here and we're going to do separate ones with it. And with that being said, I'll catch you guys on the next video. Thank you.